Today I'm going to talk about Advanced Functions Chapter 2. This video is created by Sen, Jiwaji, Keshav and Josan. So what is Chapter 2 about? Chapter 2 is about polynomial equations and inequalities. So by now you should be familiar with variables and exponents, and you may have dealt with expressions like 3x power 4 or 6x. What is a polynomial? Polynomials are algebraic expressions that add constants and variables. Coefficients multiply the variables which are raised to various powers by non-negative integer exponents. These are some of the examples where in real-life situations where polynomial equations are used. This is just an example of what a polynomial equation looks like. So in this equation you can see there are polynomials x power 3 plus 5x squared minus 4x minus 20, which equals to 0. So chapter 2.1, the remainder theorem. When a polynomial function px is divided by x minus b, the remainder is pb, and when it is divided by ax minus b, the remainder is pb over a, where a and b are integers and a is not equal to 0. There are three methods to solve the remainder theorem. The first one is long division, second one is synthetic division, and the third one remainder theorem itself to check your answer. So before we start, this is just an example. If I have 30 pieces of donuts and I have to divide them by 7 equally, I will have 4, but I'll also have 2 remainders. So the answer will be written as 4 remainder 2. So method 1 is long division. This is an example. Divide x power 3 minus 4x power 2 plus 2x plus 5 by x minus 2. So in this question you can see x minus 2 is the divisor, x power 3 minus 4x squared plus 2x plus 5 is the dividend. So once you have already written this in a division form, the second step would be x squared multiplied by x minus 2, where you have to get x power 3. So once you get x power 3, when you divide x squared by minus 2, you'll also get 2x minus squared. Minus 4x squared minus 2x squared is minus 2x squared. So you have to also find another number that when you multiply x plus x minus 2, you get minus 2x squared. So here, as you can see, when you divide negative 2x by x minus 2, you get negative 2x squared plus 4x. Again, you repeat the step. When you do 2x minus plus 4x, you get negative 2x plus 5. We still are not done as we have 5 remaining. So you bring down the 5. Again, try to find the number. When you multiply by x negative 2, you get negative 2x. So in this case, it's negative 2. The answer will be negative 2x plus 4. You do the same thing. 5 minus plus 4, which is 1. So our answer can be written as, you have seen the remainder is 1. Our answer can be written as x squared minus 2x minus 2 plus 1 over x minus 2, where this is our quotient, this is our divisor, and this is our remainder. This is known as the quotient form. Method 2, synthetic division. An example: 2x power 4 minus 3x power 2 plus 4x minus 9 divide by x plus 2. So first, x plus 2, when you draw it in a graph, it will be negative 2 on the negative 2 side. So you write negative 2 here, you put in the digits 2, 0, as there is no power 3, so you put in a 0, negative 3 for the squared, 4 and negative 9. So the first thing would be drop the 2 down here. Negative 2 times 2 is negative 4. 0 plus negative 4 is negative 4. You do the same thing again. Negative 2 times negative 4 is 8, positive 8. So negative 3 plus 8 is 5. Then you continue doing the same thing. Negative 2 times 5 is negative 10. 4 plus negative 10 is negative 6. Negative 2 times negative 6 is positive 12. Negative 9 plus positive 12 is 3. So this is our remainder 3. The answer can be written as, this is our question, which is our dividend. This is our divisor. So the answer is 2x power 3 minus 4x squared plus 5x minus 6, which now this is our quotient, plus 3 the remainder over x plus 2 our divisor. Method 3, the remainder theorem. This is to determine and verify the remainder theorem. When we divide a polynomial fx by x minus b, the remainder r equals f over b if it's equal to 0. Example, 2x power 2 minus 5x minus 1 divided by x minus 3. We are continuing the above example. We don't need to divide by x minus 3, we don't need to do long division or remainder theorem. We just calculate f, we just put x as 3. So 2 bracket 3 power 2 minus 5 bracket 3 power negative 1 is equal to 2. And that is the remainder we get from our calculations above. As the remainder is 2, this means that x minus 3 is not a factor of 2x squared minus 5x minus 1. Chapter 2.2, the factor theorem. X minus b is a factor of a polynomial px if and only if pb is equal to 0. So a factor is only when the function equals 0. The same thing with ax minus b is a factor of px if and only if pb over a is equal to 0. Not pb must equal 0. When used with synthetic or long division, the factor theorem provides a method of factoring polynomials of any degree assuming they are factorable. By determining values of x such that px is equal to 0, we can determine factors of px, then perform a division to reduce the degree of the polynomial. So the factor theorem. This is an example. Factor fx, x power 3 minus 3x power 2 minus 50. So you should test value of x to find a factor of fx. This can be done by using a calculator. Once you put this in the y is equal to, you graph it, then press second, trace and value. So when x is equal to negative 1, it comes as negative 52, so x minus 1 is not a factor. When you put in 2, it comes as negative 54, so x minus 2 is also not a factor. When f put into 3 is equal to negative 50, so x minus 3 is not also a factor. When you put it as x negative 4 is also negative 34, so x is not a factor. But when you put it as 5, which equals 0, so this means x negative 5 is a factor. We can also determine this by using synthetic division to determine the quotient when fx is equal to x power 3 minus 3x squared minus 50. The same thing, put the 5 on this side. The numbers, as you can see, the leading coefficient here is 1, negative 3, 0 as there is no x, and 50 for the negative 50. So the same thing, put 1 down. 5 times 1 is 5, minus 3 plus 5 is 2, 5 times 2 is 10, 0 plus 10 is 10, 5 times 10 is 50, 50 minus 50 is 0. So as you can see, the remainder here is 0. Therefore this means x minus 5 is a factor of x power 3 minus 3x squared minus 50. So from this we can say fx is equal to x minus 5 x squared plus 2x plus 10. As you know, this is the quotient found, and this is a factor that we know is equal to 0. So this is one of the factors of fx. Example 1, the integral 0 theorem. So what does integral 0 theorem mean? If x minus b is a factor of the function when the leading coefficient is 1 and remaining coefficients are integers. For example, factor fx is equal to x power 3 plus 6x power 2 minus x minus 30. So the factors of negative 30 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, and plus or minus 30. Since f, when you put in 1 again, is negative 5, this means x minus 1 is not a factor of fx. Since f, when you put in 2, is equal to 0, when you put 2 means putting it into x is 0, so x negative 2 is a factor of fx. Here we have only taken the factors of negative 30. This is because the leading coefficient here is 1. As said, integral 0 theorem is when the leading coefficient is 1. So this is it. X power 3 plus 6x squared minus 6x minus 30 is fx. When you put it into 2, we can check it using the remainder theorem. When you change x to 2, so 2 bracket 3 power 3 plus 6 bracket 2 power 2 negative 2 negative 30. As you can see, it equals to 0. We can use long division to find other factors. So as we know that x minus 2 is already a factor, so we can put it into the dividend. Again, we have to find for x a polynomial that when you multiply by x minus 2 is equal to x power 3. So in this case, x power 2. So we get it. Then bring 6x squared minus 2x squared is 8x power 2 minus x, bring the minus x down. A polynomial that when you divide you get 8x squared is 8x. So negative 8x squared negative 16x. So this and this goes, negative x minus negative 16 is 15x. Again, find a polynomial that when you divide by x minus 2 you get 15x, in this case 15. So 15x minus 30. Once you bring that negative 30 down, so it's 15x minus 30, the remainder is 0. So we can conclude by saying x minus 2 is already one of the factors, and the other two factors in this case will be, as this is a power 3 function, is x power 2 plus 8x plus 15 is a factor of x power 3 plus 6x squared minus x minus 30. So the factors of fx which is equal to x power 3 plus 6x power 2 minus x minus 30 are x minus 2, x plus 3, x plus 5. This is because once you simplify this, it will equal to x plus 5 and x plus 3. The rational zero theorem. This is if px is a polynomial with integer coefficients and if b is a. So for example, in this case the leading coefficient can be 2, 3, 4, 5, 6, as long as it's an integer. It can also be a negative number. Rational zero of px, then b is a factor of the constant term of px, and a is a factor if the leading coefficient. Note, px is equal to 0 for p, b over a to be a factor of px. A is not equal to 0. This is an example. List all possible rational zeros for fx is equal to 2x power 3 minus 5x plus 6. So the factors of the constant term for 6, this is the constant term, are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Factors of the leading coefficient are, the leading coefficient here is 2, are plus or minus 1 and plus or minus 2. By the rational zero theorem, the possible rational zeros of fx are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1, and plus or minus 3 over 2. Example 2. Determine the real roots of fx is equal to 2x power 3 minus 3x power 2 minus 10x plus 15 by the rational zero theorem. The possible rational zeros of fx are, as you can see again, plus or minus 1, plus or minus 3, plus or minus 5, plus or minus negative 15, plus or minus 1 over 2, plus or minus 3 over 2, plus or minus 5 over 2, and plus or minus 15 over 2. Why is this over 2? This is because the leading coefficient here is 2. So a possibility is that one of the factors can be 15 divided by this 3 divided by the leading coefficient. Since f 3 over 2, which is 1.5, is equal to 0, this means 2x minus 3 is a factor of fx. Remember, we do this by using the second trace value method on the graphic calculator. Here it is. Since 3 over 2 is equal to 0, 2x minus 3 is a factor of fx. Again, we can use synthetic division to prove this, and here it's done. Bring the 2 down. 3 over 2 times 2 is 3, minus 3 plus 3 is 0, 3 over 2 times 0 is 0, negative 10 plus 0 is negative 10, negative 3 over 2 plus negative 3 over 2 times negative 10 is negative 15, 15 plus negative 15 is 0, so the remainder is 0. In this case, 3 over 2 is a factor. So we can write fx as 2x minus 3, x squared minus 5. Since x squared minus 5 is equal to x over square root of 5 negative 5, x plus positive square root of negative 5. The real roots are 3 over 2 and plus or minus square root of 5. As you can see this in a graph, square root of 5 is negative 2.236. So I've prepared some questions for you guys to solve. These are some practice questions, just a few of the questions for chapter 2.1 and 2.2. I hope this helps you. These are the answers to the questions. After you have solved all the questions, you can look through and see where you have gone wrong.
We will be solving polynomial equations of degrees higher than 2 by using factor theorem. Also, we'll be finding the relationship between the roots of polynomial function and the zeros of the function. Example 1. Solving polynomial equations by factoring. As we can see here, the equation must be equal to 0. Then, factor out the common factor, which in this case is 3. Then we shall set each factor to 0, forming equations x plus 4 equals to 0 and x minus 3 equals to 0, resulting x equals to negative 4 and x equals to 3. We can check the solution by subbing into the original equation. Next, example 2. Determining the roots of polynomial equation. Our equation here is x power 2 plus 1 and x minus 4 equals to 0. By timesing it, we will get x power 3 minus 4x power 2 plus x minus 4 equaling to 0. The leading coefficient is 1 in this equation. With that, we will need the factors of 4, which are negative 1, 2, 4. With this, we can check the answer by subbing into the equation, which will get 0. And here is the solution. Next, determining the roots of a non-factorable polynomial equation. Our equation here is x power 3 minus 4x plus 2 equals to 0. Since the only factors are 1 and 2, neither of which makes the left side of the equation equal to 0 when tested. So this is why technology is required. With that, we come to the key concepts of this subtopic. The real roots of polynomial equation px equals to 0 correspond to the x-intercept of the graph of the polynomial function px. The x-intercepts of the graph of polynomial function correspond to the real roots of the related polynomial equation. If a polynomial equation is factorable, the roots are determined by factoring the polynomial setting is factor equal to 0 and solving each factor. If a polynomial equation is not factorable, the roots can be determined from the graph using technology. Next subtopic, families of polynomial functions. This section will be learning about families of functions is a set of functions that have the same characteristics. Next, the polynomial functions with the same zeros all belong to the same family. Next, the graphs of polynomial functions that belong to the same have the same x-intercept but different y-intercept, unless 0 is one of the x-intercepts. Also, we'll be determining the equations for a family of polynomial functions from set of zeros. Here's an example graph of a family of functions. So an example of it would be determined. We will learn that family of functions is a set of functions that have the same characteristics. Polynomial functions with the same zeros all belong in the same family, and the graph of a polynomial function that belong to the same family have same x-intercepts but different y-intercepts, unless 0 is one of the x-intercepts. Also, we will determine the equations for a family of polynomial functions from a set of zeros. When they mention equation, we will always use the y equals to k bracket a minus x, continuing with all the rest of the factors. Here is an example graph of families of polynomial functions. K represents the vertical stretch, and we can see here that all the x-intercepts are the same. Example 1. Determine an equation for the family of a quadratic functions that has x-intercepts at 2, 5 and negative 1. Since the x-intercepts are at 2, 5 and negative 1, factors are x minus 2, x minus 5 and x plus 1. Since the intercepts are at x minus 1 has order 2, an equation is y equals to a bracket x minus 2, x minus 5, x plus 1 power 2. Example 2. In this type of question, they will give us the x-intercepts, which here are 2, 5 and negative 1, and a point, which is 1 and negative 48. First, we will have to sub in all the x-intercept into the equation, which we have here is y equals to a, x minus 2, x minus 5, x plus 1 power 2. Then we substitute the x, which is 1, and y, which is negative 48, and solve for a. So as we can see here, a will equal to negative 3, and the equation is fx equals to negative 3, x minus 2, x minus 5, x plus 1 power 2. Example 3. Determine an equation for a quadratic function shown below. In this type of question, a graph will be given, and as we can see here, the x-intercepts as well, which are negative 1, 2 and 3. How to solve this is we've used the form equation and sub in all the x-intercepts, which we will get x plus 1, x minus 2 and x minus 3. To find the specific equation, use a clear point on the graph such as the y-intercept in this case. So here we will use the point 0, 12. So negative 12 equals to a, 0 plus 1, 0 minus 2, 0 minus 3 minus 12 equals to 6a. And a will be equal to negative 2. And here is the final equation. Question. Solve these questions here. I will pause the video for a short while for you to look at the questions, and after this the answers will be given.
Hi, my name is Joseph and I'll be talking about chapter 2.5, which is Solve Inequalities using technology. In this section, you will learn the meaning of a polynomial inequality and examine methods for solving them using technology. There are 3 methods to solve a polynomial inequality. So how to solve a polynomial inequality graphically using method 1. Given example 1, solve the inequality x to the power 4 plus x cubed minus 2x squared minus 2x. First, you have to use the graphic calculator to graph a corresponding polynomial function, which is fx equals to x to the power 4 plus x cubed minus 2x squared minus 2x. This graph will get this as a result. A given x will solve the inequality if fx is greater than or equals to 0, and fx is above the x-axis. Thus, the set of our solutions is the part of the x-axis indicated below in blue, the union of the following 3 intervals. Next, use the zero operation. To do that, you have to click second, then cal, then 2 on the graphic calculator, and you'll get 4 zeros, which are 0, 1.4, negative 1.4, and negative 1 to 1 decimal place. The alternate method can be solved numerically by using the roots of the polynomial equation to determine the possible intervals on which the corresponding function changes from positive to negative and vice versa. Once the intervals are established, a value from each interval is used to test if the function is positive or negative in the interval. For example, solve the inequality t cubed plus 0.8 t squared minus 2t minus 99 is greater or equals to 0. First, graph the function y equals to x cubed plus 0.8x squared minus 2x minus 99. Before that, please make sure that your window variables for x is between negative 10 to positive 10, and for y is negative 200 to positive 200. And you get this graph as a result. Based on the graph, there is one x-intercept, which cannot be read easily from a graph. It is located between 4 and 5. Use the zero operation to find its roots. Chapter 2.6 Solve factorable polynomial inequalities algebraically. In this subtopic, you will learn how to reverse an inequality sign when each side is multiplied or divided by a negative value. You will also understand the similarities between a solving linear inequality and a polynomial inequality. But how? Solving linear inequalities is very similar to solving linear equations. However, when both sides of an inequality are multiplied or divided by a negative number, the inequality sign must be reversed. For example, solving a linear inequality. Solve the linear inequality negative 3 minus 2x less than 7 and show the solution on the number line. So negative 3 minus 2x less than 7 will give you negative 2x less than 7 plus 3, followed by negative 2x less than 10. Therefore, x is more than negative 5. As you can see the number line, the red line represents x, which shows that x is more than negative 5. Next, how to solve a polynomial inequalities algebraically in two methods. Method 1. Consider all cases. Bracket x plus 3 multiplied by bracket 2x minus 3 is greater than 0. A product Mn is positive when m and n are both positive or both negative. In case 1, x plus 3 is greater than 0, which gives you x is greater than negative 3, as well as 2x minus 3 is greater than 0, 2x is greater than 3, x is greater than 3 over 2. X is greater than 3 over 2 is included in the inequality x is greater than negative 3, so the solution is x is greater than 3 over 2. In case 2, x plus 3 is lesser than 0, x is lesser than negative 3. 2x minus 3 is lesser than 0, which gives you 2x less than 3, therefore x is less than 3 over 2. X is lesser than 3, negative 3 is included in the inequality x is lesser than 3 over 2, so the solution is x is lesser than negative 3. However, combining the results of two cases, the solution is x is lesser than negative 3 or x is greater than 3 over 2. For method 2, use the intervals. The roots of the equation bracket x plus 3 multiplied by bracket 2x minus 3 equals 0 or x equals to minus 3 and x equals to 3 over 2. Then use the roots to break the number line into 3 intervals. These are the 3 intervals. Then test the value for x for each intervals. The first interval, test x equals to negative 4. To do this, put negative 4 into the brackets where x should be. You get 11. Since 11 is more than 0, x is less than negative 3 is the solution. For the second interval, test x equals to 0. You get negative 9. Since negative 9 is lesser than 0, x is greater than negative 3, and x is lesser than 3 over 2 is not a solution. For the third interval, test x equals to 2, and you get 5. Since 5 is greater than 0, x is greater than 3 over 2 is a solution. All of this information can be summarized into this table. From this table, we can conclude that the solution is x is lesser than 3 or x is greater than 3 over 2. Here's another example involving a factorable polynomial inequality. Given the question that a rectangular in the ground pool is to be installed, the engineer overseeing the construction project estimates that at least 1,408 meters cubed of earth and rocks need to be excavated. What are the minimum dimensions of the excavation if the depth must be 2 meters more than a quarter of width, and the length must be 12 meters more than 4 times of the width? Based off the given information, h is equals to 1 over 4w plus 2 and L equals to 4w plus 12, with L is more than 0. W is more than 0 and H is more than 0. From the formula V equals to LWH. Bracket 4W plus 12 multiplied by W multiplied by bracket 1 over 4W plus 2. You'll get 4W cubed plus 11W squared plus 24W. Since the volume must be at least 1408 meters cubed, V is greater or equals to 1408. That is W cubed plus 11W squared plus 24W greater or equals to 0. The factors of the corresponding polynomial function are W cubed plus 11W squared plus 24W minus 1408 equals to bracket W minus 8 bracket W squared plus 19W plus 176. Then solve bracket W minus 8 multiplied by bracket W squared plus 19W plus 176 greater or equals to 0. Please take note that W squared plus 19W plus 176 can be factored further. In case 1, both factors are non-negative. W minus 8 is greater or equals to 0. Therefore, W is greater or equals to 8. Since W is greater or equals to 8, then W squared plus 19W plus 176 greater than 0 is true for all values of W. This includes values for W greater or equals to 8. So W equals greater or equals to 8 is a solution. For case 2, where both factors are non-positive and W is positive because it represents the wave. Since W is greater than 0 and W is lesser or equals to 8, W squared plus 19W plus 176 is lesser or greater to 0. It's not possible for any values of W. There is no solution. So the possible solution is W greater or equals to 8. When W equals to 8, H equals to 1 over 4 multiplied by 8 plus 2, you get 4. And L equals to 4 multiplied by 2 plus 12 and you get 20. The dimensions of the excavation that give a volume of at least 1408 cm cubed are width 8 meters, depth 4 meters and length 20 meters. And that brings us to an end of chapter 2, where we learned the remainder theorem, the factor theorem, the polynomial equations, the families of polynomial functions, solve inequalities using technology, and solve factorable polynomial inequalities algebraically. Thanks for watching.